Welcome all of you to Animaths. In today's video, we shall be taking up questions in exponents which are using the rules of exponents. Okay, as we have already learned the rules of exponents in our first video, part 1 of exponents. Okay, so this video will take up sums based on rules. You will see how we can solve big questions in exponents, the sums that you weren't able to do all this time because you didn't understand which rule we were using where. We shall be doing sums based on those 5 or 6 rules that we have in exponents. Okay, so these are going to be a few basic, as well as today I shall be taking up some difficult question in this chapter. Generally, these are the questions that are asked in your question paper for about 3 marks, 4 marks towards the end of the question paper. Okay, so these are, and very commonly, the questions that I'm going to take up are the ones very commonly asked in your exams. Okay, so I'm going to take up those sums and see how I simplify them. Let me know if you find this chapter easy after watching my videos. Okay, I would love to see your comments where you tell me how you feel, how has the chapter got simplified after watching the videos or not. Okay, so let us start then. So let's take up the first example now. 4 by 9 to the power 6, okay, into 4 by 9 to the power minus 4. Now you'll see how we'll be using the rules over here now. Okay, so let's see. This is, the base is same, okay, and the powers are different. So we'll be using the first rule here, which is a to the power m into a to the power n is equal to a to the power m plus n. Okay, so 4 by 9 to the power 6 minus 4, which is equal to 4 by 9 to the power 2. So this is our final answer. We have seen the bases. First thing, we need to check that the base is same. Once the base is same, we will add the powers. The powers can be one positive, the other negative, like in here, but we have used integer working over here. So, and we have subtracted it basically. So though it is addition, but we have actually subtracted because of integer calculations, and then finally we got a 2. Okay, so this is our final answer. Now this is in the exponential form, of course. If they want it in the rational form, then you will have to make it 16 by 81. But here they have not asked for it. They have only asked you to get the value of this in exponential form. So we used the rule and did it. So please don't write this 6 times and write this 4 times and do all that. That is not what they are asking you to do. Then 5 to the power minus 3. Okay, this is a sum where they are telling you write it in the form of a rational number. Here we know that if we take the number from the numerator to the denominator, basically if we take the exponential number from the numerator to the denominator, we'll get a change in the sign of the power. So 1 by 5 to the power 3. Because we took the 5 down, the 3 became positive. Okay, since the 3 became positive, now which rule did we use? A to the power m is equal to 1 by a to the power minus m, or even you can say a to the power minus m is equal to 1 by a to the power m. Both are correct. Okay, so here we have not yet reached the rational number. We have only got it to the positive power. Remember, we can't work with this. Okay, this is one thing we can't work it. So here I have 125. This is my final answer, which is I have converted it to rational number. Okay, then let us take up the next one, which is minus 2 to the power minus 5. Now you see there's a negative here and there's a negative here. Now as I've already told in my last videos that there's a very common tendency to multiply this minus with minus, and I've got something plus, they'll say. So please don't calculate with this and this. They are not supposed to be calculated ever. Okay, you are not supposed to work with them. So here again, the first thing that I note here, I'm supposed to convert this to a rational number. That is the question. I will have to make this positive. Otherwise, I'll not be able to convert it to a rational number. So what I do, the number is already negative. I just keep the negative sign, and I have already noted that this is an odd number. Since it is an odd number, I'll have to keep going, keep retaining my minus sign. I can't remove it. Had this been a positive number, an even number, could have made this positive. But with odd numbers, the negative remains. So this is 1 by 2 to the power 5. That is, I brought the 2 down, minus remains as it is, don't touch it, and then this 5 comes down, it becomes 1 by 2 to the power 5. I have used the rule of exponents, that is a to the power m is equal to 1 by a to the power minus m. I have used that rule, okay, and that comes to now minus 1 by 32, okay, because 2 to the power 5 you can calculate and see, that is 2 into 2, 4, 4 into 2 is an 8, 8 into 2 is an 16, 16 into 2 is a 32. So 2 to the power 5 is a 32. So this is my final rational number that they had asked for, with the minus sign, of course. Okay, then let me take up another number. Here we'll see a fraction. Minus 3 by 4 to the power minus 3. Now the moment it changes from a regular number to a fractional number, again some kind of confusion starts. We don't need to get confused. This is, now again, if we do reciprocal of this, we can remove the negative sign, and this is already odd. Since it is odd, this minus will remain. Okay, we cannot remove this minus sign if it is odd, because with even what happens, minus comes in pairs, that is minus into minus. If you write 4 times, minus into minus is a plus, again minus into minus is a plus. So plus into plus is a plus, but here with the odd power, the minus remains. So I'll just keep the minus and I'll write 4, okay, and by 3. I'll write 4 by 3. Write the bracket, don't take this minus outside. Again it goes wrong like that. This minus has to be inside. And then put the 3 here. Okay, so it is the same number written with a positive power now. And if it has been written with a positive power, now I can take it out. I'll take it out and minus 4 to the power 3, which is 4 into 4, 16, 16 into 4, 64. Okay, so it is 64 by 27. That is, how is it 27? Because it is 3 into 3, 9, 9 into 3, 27. So this is my final rational number. No need to write it in the mixed form or anything, you can leave it like that. So we are using the rule of exponents. Now here comes a sum which most of the students get it wrong, except for the ones who get 90 plus. They are the only ones who get this correct. Otherwise, everybody gets it wrong. This is 5 to the power minus 1 minus 7 to the power minus 1 to the power minus 1. Now what to do about this? Now see, the moment people see this, they will multiply this minus with this with this. No, it's not to be worked like that. What we do is, first work on this much portion, okay, which is 1 by 5. Why? I'll tell you. Because there is no rule in exponent. Of all the 5 rules that you have learned, there is no rule in exponent where you work with a minus sign here or a plus sign. You will notice that all the rules are working only on what? All the rules are working only on multiplication or division signs. Okay, so here I'll retain the bracket, minus also will be written, and a 7, and this minus 1 to be written. I'll first complete with my bracket, and only after that I'll be using that minus sign. Okay, so now LCM is a 35. Okay, if LCM is for 35, 7 minus 5, which is a 2 by 35 to the power minus 1, which is equal to 35 by 2. Okay, so this is equal to 35 by 2. So this is my final answer. Okay, so the next sum is minus 1 by 4, okay, and a bracket, and then to the power 2 outside the bracket. Okay, here goes to the power 2, minus 1 by 4 bracket to the power 2, then comes a curly bracket, another 2, and then comes a square bracket. Now you write a minus 1. This is my sum, and they have asked me to find the value of this sum. Okay, now here we shall be using the rule a to the power m to the power n is equal to a to the power m n. We'll be using this rule now. Now what we do, we don't touch this. We don't start from the inside, rather we start from the powers. Okay, so what we do, minus 1 by 4 2 into 2, I am doing this part, okay, into minus 1, which is minus 1 by 4, and what do I write? To the power minus 4. Now I can't work with the negative exponent, I have to get rid of it. So what will I do? And this minus can be gone now, you can go, delete this, you can remove this minus now. Why? Because there's an even power, so this minus can go. So I'll write 4 to the power 4, means this minus I have actually done a reciprocal for this. When I did a reciprocal, this power became positive, so I have a plus 4, and because of this even number, this minus is gone. So my answer comes to 256. 4 into 4 is a 16. 16 into 4 is a 16 into 4 is a 64, and then comes 64 into 4 gives us a 256. Okay, so now let's do another question. Now this is a very common question, very commonly asked in the question paper. This is, see, 3 by 5 to the power 3 into, then comes 3 by 5 to the power minus 6. This is equal to 3 by 5 to the power 2x minus 1. 2x minus 1. Now the moment we see this sum, we have to note one thing, that the powers are different definitely, but the bases are same on both sides of the equal to sign. Okay, so we shall be using the first law of exponent, which is a to the power m into a to the power n is a to the power m plus n. Okay, and then so 3 to the power 5, 3 minus 6 is 3 by 5, 2x minus 1. Okay, so 3 to the power 5, 3 minus 6, 3 by 5, 2x minus 1. Here this is, you can note on both sides I have the bases same, the powers are in a different form. Not that, you know, it is not that I don't say they are different. They are in a written in a different form, and they have asked us to find the value of x in this question. Okay, so they are saying find x. X is here, not this side. Now what to do? There will be some sums where you'll get the x this side also. Now, if the two exponential numbers are same, the idea is this: if the two exponential numbers are equal because of the equal to sign, the bases are also equal, then the powers must be equal. That is the logic we use here. Okay, so since the bases are equal, now we can equate the powers. This side 3 minus 6, that's a minus 3, and 2x minus 1. Bring that minus 1 this side, becomes a plus 1. This is 2x. This is minus 2, 2x. X is equal to minus 2 by 2, which is equal to a minus 1. Okay, so this is equal to a minus 1 now. So we have our answer, x is equal to minus 1 for this sum. We'll do another sum. of this type only. Let us take up another sum so that it becomes very simple for you all. Let me take up a quick sum, exactly this type. 5 to the power 2n into 5 to the power 3, okay, that is 5 to the power 9. They are asking us to find the value of, find n, here is n, okay. Now again base is same, let us add up the powers. So 5, this is the first law of exponents we are using, 2n plus 3, that is equal to 5 to the power 9. Now bases is same, as I said, numbers are equal on both sides, hence powers have to be equated. 2n plus 3 is equal to 9. Yes, so 2n is how much? So 2n is equal to 6 then. 2n is a 6 then, okay. If 2n is a 6, n is equal to 3. That is my answer, okay. So again these two sums are exactly similar, you can see. So the moment you see this sum, you have to first note that are the bases same. If the bases are same, this is the way you work it out, okay. Then so with this we end up with the types of sums in that can be asked in exponents. So if you have found the video useful and you like the video, do not forget to like, share and subscribe. I shall be putting all the links of the other videos of exponents. There are exponents is there in 4 parts, okay. All the links you'll find in the description box. So if you want to see those for clearing your doubts, you can go to the description box and you'll find all the links there, okay. Then bye all of you, see you in the next video where we shall be doing changing a number from usual to standard form or from standard to usual form. Thanks all of you.